Hello everyone. So I thought I'd make a little video recording since we have an interesting situation here in our production cluster, which is that the database 6 node is very flaky. We can see here in our Kubernetes events channel, which has a log of all events happening in Kubernetes. If we filter for database 6 has, we can see that it has been rebooted over and over and over every few days or so. And if we go into our Grafana and drill down for this last time that we saw a reboot, which was around 1 o'clock at night here on the 19th. We do find some error logs on our Talos host database 6. And in here, if we search for hardware, we do find these hardware errors. And this line here, it is the one that shows us that the CPU core number 0 has encountered an unrecoverable error. That's the UE. And this is resulting in a system fatal error. And if I would keep drilling down in all these time slots, then we would find the same kind of error, something about the CPU. So what can we do about this? We want to now replace the database 6 node. We can start by looking at what is running on it. So this is the nodes view in K9s. We can head over to database 6. And the only thing we have deployed here is actually these two Elasticsearch clusters. And so what we want to do now is we would like to reschedule these Elasticsearch pods on another node. But because we are using local persistent volumes, these pods are actually locked to database 6 because that's where the data resides. So how can we deal with that? So one way of doing it is to cordon the node. And this prevents any workloads from being scheduled on this node. And I'm just going to show this one right now. We're not going to do the other one, but just to have a look at what we can do with these Elasticsearch clusters. So if I hit Control D for delete here, and I delete, then it will go into terminating state for this pod. This might take a little while because Elasticsearch will try to do everything gracefully and make sure that everything shuts down correctly. Meanwhile, maybe we can have a little look in Kibana for this cluster. So for example, we can head over to the nodes section and we can see the shard distribution on these pods. We have a fairly even distribution of about 320 shards per node. And so this is default number 1. So it's just been fully terminated. And so what would happen then if we nuke this, then we will lose the shards on this node. And okay, now they're not available, which is expected, it's not running. If I change the view here now to just a regular pods view and I sort by age, we can see that we have this pending media monitor default pod. And why is it pending? We can describe it and head all the way down here and we can see the events. So it is not schedulable because 0 out of 30 nodes are available. And this is because we have cordoned the only node to which it could actually be scheduled, which is where it has its persistent volume. So what can we do now to make it actually rescheduled on another node? We could use the k node purge PVCs command, which the first argument here is the node. So running this is generally safe. It will not actually delete anything until you accept the prompt. But we can see here that it has 2 PVCs, one for each of these Elasticsearch clusters. And in this case, we're only working on one of them. So if I copy this and I exit out of there and I give that persistent volume as a second argument, Now I can delete only that one. So now the persistent volume is deleted. So we should be able to schedule now. So just to make it quickly rescheduled, I'm gonna delete the one which is pending, which makes it go through the scheduler immediately. And we can see that it is now initializing on database 4 instead. So one thing we can also do in general is to use, I like to use the kubectl plugin resource capacity, which you can install via crew. And this gives you an idea of the where you might have space on different nodes. So if I grep for database here, we can see that, okay, it's scheduled on database 4, which is probably because we had, a lot of free resource available there. So in general, Kubernetes will schedule workloads on the node which has the least amount of capacity in use right now. So if we head back here, we can see that it's still initializing. We could hit L to follow the progress in the logs, but basically we just have to wait. It takes a while for Elasticsearch to initialize on a new node. Another thing to monitor is we do kubectl get Elasticsearch. We can see that we are in the phase applying changes, which indicates that the operator is busy rescheduling a pod on a new node. We can also see that the health is yellow. Yellow means that we have access to all data and we can write new data. However, we have shards which are not fully replicated on another node, which is because, of course, we just removed one of the nodes. Keep waiting for this one. We are now going through the init containers, and those seem to be done. So we have pod initializing, and one is ready. And two are ready. So if I do this again now, we should see that the phase is now ready, but the health is yellow. So if we head back to Kibana here, so we can see that, okay, we lost this one, but we have a new one, a new ES default one. And we will also see that it's now starting to get shards. So when you lose or we can say replace a node in Elasticsearch, it will immediately, or like when it realizes that, okay, you've lost a node, it would start to redistribute all the yellow indexes onto available nodes. So now it looks like, and it's going to try to balance them. So if there is one node which has less shards than the others, it will prioritize adding shards to that node. But if this is taking a long time, it might also start to actually distribute to each other, to the ones which are already quite populated. And this might also take quite some time. I think we were dealing with about 500 gigabytes of data. And from my experience, this can be quite slow, even though you might think that you have a network of 1 gigabit per node, so it should be quite fast to reconcile the data. That's not actually the speed at which Elasticsearch will work. It might work at around 20 megabytes per second or so. So this will probably take a few hours to fully reconcile. But nevertheless, that's the process that we can do here. And I believe in the latest version of the platform, we might have actually a different approach. Maybe I can have a look at that. And let's head over to get started. If you have a look at the default templates that we provide for Elastic, yeah, so we have yeah, okay, so this is not, yeah, this is the same. So you would have to do what I'm doing here when you're doing this. But I do believe we have another approach. Yeah, this is the one. So this is probably what we will actually end up doing instead, which is to use named replicas instead of just a number of replicas. You actually give each replica a name. And by doing that, instead of just nuking the PV for a pod to get rescheduled elsewhere, you could instead, from your values, you could remove the specific replica from your cluster and have their operator downscale and maybe upscale it to another node. And you wouldn't have to deal with the persistent volumes. But I thought this could be interesting to look at anyway, because this is a trick which you can apply to more or less all kinds of database workloads which are replicated. So Postgres, Redis, if you get stuck or if a node dies, if you remove the PVC with the k node purge PVCs command that we were running here, then those pods should be rescheduled. So it's quite useful. And so, of course, later on, whenever I have time, I will do the same with the next Elasticsearch cluster, wait for it to be fully reconciled and in a green state. So once all the yellow indexes are done replicating, we will be back in green state. And at that point, I would be happy and cancel the old server. And also, so I don't forget, I'm gonna now uncordon database 6, just in case it does decide to reboot suddenly. We don't want all these pods to be stuck. So hope you learned something. Bye-bye.